Hi everyone, I'm making this video to help you study. To use it effectively, you'll want to pause the video when I tell you and try it yourself. If you follow that advice, you will learn a ton. If you just watch the video, you're not going to learn much. Okay, read the first question, number 1. So this is wrong because when you pull a scalar out, you have to pull it out with the absolute value. So A is not correct. If C is negative, then CA flips direction, so it's opposite direction to A. Yep, that's correct. This vector is a vector divided by its length. So if the vector had length 3, you divide it by 3. Now it's a unit vector. That means its length has 1. And it has the same direction as the original. So that's correct. For D, if the length of A plus B equals, so this is it's going to be impossible to understand this until you draw a picture. Let's draw them parallel and point in the same direction. So maybe that's A, and that's B. Those are parallel and in the same direction. If we pointed B this way, then they would have different directions and be parallel. But now, how do we do the addition of vectors? Well, we can just pull the vector A and put it at the start of B and put it like that. And then this whole vector here is A plus B. So that's A plus B. And sure enough, the length of A plus B is just the length of A, the length of A plus the length of B. So this is true in the case where they say, where A and B are parallel and point in the same direction. Now, if they point in any other way, so like if this was A and this was B, then you see A plus B is going to be that vector, and it's going to be slightly shorter than A plus B because it's turned. So this is true. Okay. Read question number 2. Pause the video and read it. Try to solve it. Okay, so it's important to draw a quick picture. We've got P somewhere, Q somewhere, and then the vector A is Q minus P, final minus initial. So I draw it ending at Q, and that's the vector A, it's Q minus P. Okay, so that's my picture. Now I have to think, okay, the set of points P plus TA, where T is allowed to range just between 0 and 1. Well, if T is 0, I'm just going to be at P, and if T is 1, I'm going to be at P plus A. But you can see if I start at P and I do plus A, I'm at Q. So, and then when T is a half, I'll be halfway. When T is a quarter, I'll be a quarter of the way. When T is 3/4, I'll be 3/4 of the way. And so this is correct. It gives you the line segment between P and Q. That's correct. Like I said just a moment ago, the midpoint is when T equals a half. So yeah, that's correct. The midpoint is also given by this, and you can see that by the definition. So P plus a half A, we know is that's the midpoint. But what's A? A is Q minus P. And so if we have a half Q minus a half P, and we started with a P plus that, then the P and the half P will cancel, and we'll get just positive 1/2 P. And so we've got a half Q and a half P. That's the same as P plus Q divided by 2. So this is also true. The velocity vector of the parametrization. Well, remember, the velocity vector is dx dt. So if I do that, well, P is constant, so its velocity would be the 0 vector. And then T times A, d dt gives me A. Okay. And if you want in coordinates, you could write out, P1 plus TA1, P2 plus TA2, P3 plus TA3 is like the coordinatization of capital X of t. And we just apply d dt, the time derivative, to each piece separately. And sure enough, now P sub 1 is just a number. and it doesn't depend on t, so its derivative is 0. Whereas this one, just like d dx of 5x was 5, d dt of ta1 is a1. And so if we do d dt to this, we get a1, a2, a3, which is just the vector a. So when they say the velocity vector is q, that's false, because the velocity vector is a. So if you have a parameterization p plus ta, a is the velocity vector. It's the direction of your movement. So this is false. Okay. Let's skip these two for now and move on to one of these exercises. Okay, so right now you should try to at least do the first sentence of number 9. Okay, welcome back. You should have tried it yourself. First, ignore the coordinates for now and just have a picture. We want to find the coordinates of the point x that lies 1/4 of the way from P to Q. So I just draw a picture. Here's P, here's Q. How do I get 1/4 of the way there? Well, I can form capital A equals Q minus P, and I can just do P plus 1/4 A. And that's it. And if I just do this out, if I compute the coordinates, I will get the correct answer. And now, only now after I have my picture and I know that this is going to be the answer, P plus 1/4 A, now I go ahead and compute all these things. So P is the vector 2, 1. And what's A? A is Q minus P. So Q minus P is 8, 9 minus 2, 1. That's 6, 8. And so I take 1/4 of 6, 8. And how do I do that? Well, it's just going to be 2, 1 plus 3 halves and a 2. I just distributed the 1/4 to each component. And 2 plus 3 halves is 7 halves. And 1 plus 2 is 3. So this is my answer. Okay, so I only do the actual numbers at the very end after I have a picture. That is a theme, and I really highly recommend you draw a cartoon picture for every problem first. Okay. You'll find you're drawing the same picture over and over again. And you notice I didn't make any attempt to make P and Q actually have the coordinates 8, 9, 2, 1. I'm telling you, completely ignore the numbers at first. Okay, just draw a cartoon. Let's find another one. Try this one yourself. Draw a cartoon for this, and I'll come back in a moment. So pause the video. Okay, so they're giving us some vectors, so I'm just going to draw some random vectors, capital A and capital B, and I want the cosine of this angle. But remember that A dot B is the length of A times the length of B times the cosine of theta. This is a theorem that comes from the projection formula and our definition of cosine as length of projection. Anyway, you don't need to know the proof. You should probably just memorize this. In fact, this is what people say is the definition of the dot product in physics usually. So now we can compute the cosine of the angle. All we need to do is compute the dot product, compute the length, and then divide. So I can do that. The dot product is 1 times 3 plus 2 times 0 plus negative 2 times 4, negative 8. So the dot product is negative 5. So this number is negative 5. So yeah, now I'm doing the numbers because I have had a clear picture and I knew exactly what to do. Now what's the length of A? The length of A is going to be the square root of 1 squared plus 2 squared plus negative 2 squared. And then the length of B is going to be the square root of 3 squared plus 0 squared plus 4 squared. And if I do that out, I get 4 and 4 and 1 is going to be 9. The square root of 3, or square root of 9 is 3. And then here I'm going to get 9 plus 16, which is 25, and the square root of 25 is 5. So my answer is that the cosine of theta is negative 5 divided by 3 times 5, or negative 1/3. Okay. Try to do this one. So pause the video and draw a picture first, okay? Okay, so let's find the parametric representation of the line of intersection. I've got these equations here, but I'm actually going to ignore them. I'm first going to draw a picture. So I've got a plane, that's one of the equations, and then another plane, and I'll draw them intersecting as they would, or as they might. And this is the line I want. So let me look back at the statement. Find a parametric representation of the line. So right away, I should think I need P plus TA. And so really, I need a P. Let's say that's P. And notice that P is on this plane, and it's on this plane. It's on both planes. So P is a solution to both equations. So I'll need to find P as solution to both equations. Okay? Now I'm not looking at the numbers yet. And then I need to find A. So how can I find A? Well, first let me draw A. Maybe A will look like this. Okay, so how do I get a vector? Final minus initial. So I can get A if I have another point. So I'll find another. And then set A equal to Q minus P. And then my answer is P plus TA. So now I'm basically done, and I just need to do the solving. So let me show you. So you see what I need to do is I need to find points on both equations. So I need to find a solution XYZ that satisfies both of these. So let me just, guessing is a great way to do it, especially when the equations look pretty simple. So how do I solve this one? Well, let's take x to be 1 and y to be 1. And then z can be whatever I want. And this is going to satisfy this. So now I'll choose z so that I can satisfy the first one. Okay, so if x is 1 and y is 1, I get 2 plus something equals 1. So z should be minus 1. Similarly, I can set 2, 2 for my xy, and this equation will be solved. And then I can solve for z. And what will z be? I'll get 4 here, minus 4, so z is minus 3. Yeah. So this can be p, and this can be q. And then q minus p is a, which I can solve. It's 1, 1. Negative 3 minus negative 1 is negative 3 plus 1, so that's negative 2. Okay, and I'm basically done. So now my line is 1, 1 minus 1 plus t times 1, 1 minus 2. That's my line. That's a parametric representation of the line. Okay, so hope you see the theme of drawing a picture first and only at the end doing the numbers. Okay. Let's try this one. Read this one yourself. Pause the video. Okay, so we've got some curve, going around through space. I'm just drawing a cartoon right now. And what's the length of it? How do I get the length of it? Well, the length, or distance, is equal to speed times time. If I go 60 miles an hour for 2 hours, then my distance I travel is 120 miles. Everybody knows that distance is equal to speed times time. You actually understand that. 60 miles an hour, you can do that for 2 hours, you go 120 miles. Okay. So what I need to do then to compute the distance is I need to add up a bunch of speeds times a little time period. And when we do that, we're calculating the length of the curve. So how do we do addition? We add up by an integral a bunch of speeds. What's the speed of the curve? It's the velocity vector, the norm, that's the speed. The scalar speed, that's the length of the velocity. And then my little times will be dt. So speed times time gives me a little distance. And the length of the curve is just the integral from, what did they say, t equals 0 to t equals 1. T equals 0 to t equals 1. Okay. fair enough. Now that I've done the conceptual work, I will actually compute these things. So now how do I do x prime? So the velocity is going to be 1, 2t, 3t squared. And what's the length of the velocity? That's the speed. And that's what I'm going to put here. Well, it's the square root of 1 squared plus 2t squared plus 3t squared squared. So my integral from t equals 0 to 1 of the square root of 1 plus 4t squared plus 9t to the 4th dt. Do not evaluate, just set up the integral. So a computer can approximate this for you, for example. And that's the length. Let's do this one. So pause the video and try it yourself. Okay, so welcome back. Let's remember, ignore the numbers at first and just do a cartoon picture. We have 2 points, A and B. We want to find all the points that are equidistant from them and show that it's a plane and identify its normal vector. So how are we going to show that something is a plane? We're going to show that the equation is n dot x equals n dot p. That is the definition of a plane. And then what is it? We'll identify its normal vector. It'll be whatever is in front of the x, y, z coordinates. That will be the normal vector. So that's the idea. Now let's do a picture. If I have a point A and another point B, and you can imagine like halfway between them, but also you could go like that, whereas this distance equals this distance, and all those points they're claiming will look like some sort of a plane. But let's just write out what's the condition that a point x have the same distance to A and the same distance to B. Well, that's just, remember, whenever you've got points, you can do final minus initial and take the length of that vector. X minus A, length of the vector, equals, let's say, x minus B, length of that vector. Now, this length is a square root of a sum of squares, but it's a little bit easier to square it both, and that's fine. And then we can use our formula, 2x dot A plus A squared. Remember, where A squared and x squared is really x dot x, A dot A. And on the right side, we can do our other formula, 2x dot B plus B squared. Now, x squared is x dot x, and it's just a number, and it's the same on both sides, so we'll just cancel it. And now let's just rearrange and try to simplify this equation. Maybe let's add this one over here. So we're going to get 2x dot b minus 2x dot a, and let's move this one over here, equals b squared minus a squared. Okay, and then remember the dot product, we can factor out a 2. In other words, we're going to get a b minus a. That's a vector dot product with x. And we also have a 2 here. And that is equal to b squared minus a squared. And what are we going to do with that 2? Well, remember we want n dot x equals n dot p. That's the plane equation. And then we're just going to pattern match. So I guess I can switch the order right here. I can also divide both sides by the number 2, and that's fine. So what I'll get is I'll get b minus a dot x equals, and now on the right hand side I'll get b squared minus a squared over 2. Now, because I don't know any point on the plane, this is just some number. And remember, like, another way to think about n dot x equals n dot p is it's n dot x equals a number. N dot x equals some number, right? So, for example, n1x plus n2y equals 5. Or 6x minus 2y equals 5 would be a line. So now you can see that this has got to be capital N. So N equals b minus a. And I might say, I might add some words to explain what's happening here. So we started with the condition for x to be equidistant. That's the word they used, I think. I wouldn't have used that word, but they said it. Are equidistant from A and B. All the points x are equidistant, okay? And to A and B. Did algebra. Found the equation of a plane with normal vector n equals b minus a. And I think I answered their question then. Find the equation. Yep, found that. Show that this set describes a plane. Yep, identify its normal vector. Yep. Okay. All right, let's try number 14. So pause the video and try it yourself. Okay, welcome back. So we got to start with a picture, a cartoon, okay? Consider the line passing through P in direction A. Okay, so I've got a point P, I've got a direction capital A, and then I've got this whole line, P plus TA. Okay? You see, I'm drawing the same picture every time. Find a formula in terms of P and A for the value of T that minimizes the distance from the origin to the point P plus TA. Which I guess they gave this the name capital X of t, okay? So now, what else? I have to add the origin. Here's the origin. I'll call it script O. And you can see, like, there's some distance from P to O, there's some distance from P plus A to O, from P plus 2A to O. There's all these distances, P plus a half A to O. There's all those distances. And what's the formula for that distance? Well, if we're at the point P plus TA, we do, how do you get a vector? Final minus initial. But the origin is 0, 0, 0, 0, 0, 0, 0, so when I subtract it, that's just the length of P plus TA. Okay, now here's the hint. The hint is minimize the square of the distance. Why? Because then you don't have to take the derivative of a square root. You know, this thing is secretly the square root of a sum of squares. And that's sort of annoying. So let's, so this is the distance, d of t, and minimize d of t squared instead. Why is that? Well, because d of t squared is p plus ta squared, which is p plus ta, by definition, dot product p plus ta. And now I can expand this out. I get p dot p, or p squared for short, plus t times a dot p, plus another t times p dot a, which is the same as a dot p. These are the same. And then finally, the last term is plus t squared a dot a, or a squared. Okay. And let's just combine these so we get p squared plus twice 2t a dot p plus t squared a dot a. So this is a number, this is a number, this is a number. And how do I minimize something? Remember, in calculus, find minimum by taking the derivative, d dt, and set to 0. Why is that? Because to find the minimum is going to be at one of the points where the derivative is 0. That's going to be the minimum of the function. It could be a maximum too, but in this case it'll be a minimum. So d dt gives, okay, I'm taking d dt of this whole thing. D dt of p squared is 0. D dt of this is twice a dot p. And d dt of this is 2t plus 2t a squared. A squared is like as a number, like 5. So it just hangs out when you take the derivative. And I'm asking, when is that 0? Well, now I can solve for t. So 2t a squared equals negative 2a dot p. And divide by 2a squared, divide by 2a squared, and I get t is equal to negative a dot p over a squared. And now let me check and see what they asked for. Find the value of t that minimizes the distance from the origin to that point. And from the picture, we know that like there's only going to be a minimum. There's no maximum because you just keep going farther and farther away from the origin, and the distance keeps getting bigger and bigger. So this has to be a minimum. So geometry says this must be a minimum. The min. And I could explain it more saying that the distance from the origin to the point on an infinite line is infinite. Like you can get as big as you want far away. You can go as far away as you want from the origin if you travel along p plus ta. So we only found one critical point, and it has to be a minimum. That's what I mean by geometry says this must be a min. Okay. So again, once you draw a picture, everything falls into a place, and then you do the calculations afterward. Okay, let me take a break, and I'll come back and do another video.